So today we're going to be doing a lab where we investigate the concept of vapor pressure. And so what I have in front of you is I have a beaker full of water. The water is clearly not boiling. I have a thermometer so we can check the temperature. And we're going to be using a syringe and a top, no needle, but the syringe itself and the top. And we're going to see what happens. But before we get that, let's do some basic introductory pre-lab questions. So at the beginning of the lab, the first question is what temperature does water boil? And so you should look that up. And then if water is below its boiling temperature or boiling point, will it boil? And everyone should be saying, no, it should not. All right, so now here's what we're gonna do. We have a hot beaker of water. We're gonna check the temperature. Hopefully you can see that. But if you can read that, I don't know if it's going in or out or not. But the water is about 73 degrees. So it says about 70. This one's gonna be about 73. And what we're going to do is we're going to take a little bit of water and suck it up in the syringe. And then we're going to put the cap on. And so if we look at the water inside the syringe, the question would be, is it boiling? And we don't see any of the characteristic bubbling that we get when things boil. So the answer is no, it's not boiling. So what we're going to do, we're going to pull back on the syringe and watch what happens to the water. So hopefully you should be able to see. It's a little bit hard, but the water inside the syringe is in fact boiling. Okay, now I let it go. And when I stop pulling, the boiling stops as well. And so there's no temperature change. If I were to feel this, I wouldn't say it got any hotter noticeably or any colder noticeably. I can't notice any change in temperature. But when I pull back, it does boil. It boils a little less each time I do it. It does it a little bit there. But that's pretty much it. If I want it to boil again, I would need to take some new water. Recap it. And then if I pull back on it, you can see the boiling happening inside the syringe. And so that water's boiling. Okay. And then we let go. So now, the real question is, something happened to make the water boil, but it wasn't a temperature thing. And it wasn't the temperature. The temperature didn't just skyrocket to the boiling point of water by me putting this in the syringe. Because as soon as I took it off the hot plate, the water actually starts cooling down the moment it comes off the hot plate and it loses its heat source. So the water's cooling down, yet something about pulling back on that syringe didn't increase the temperature, but it made the water boil through another means. So what you're gonna do is use what you know about vapor pressure and temperature, and which is going to be in the notes that we did probably right before this, and answer these questions. So under normal conditions, what temperature does the water boil? That's a Google one. Okay, what was the temperature of the water inside the syringe? I already answered that. What happened to the water when you pulled back on the syringe? Well, it boiled, we observed that. Did pulling back on the syringe change the temperature of the water? No, I didn't notice any real change in temperature of the water. It didn't get any hotter. As a matter of fact, it was cooling off. So if anything, it got lower. And what was changing inside the syringe? I want you to think about that. And 6, I want you to come up with a hypothesis as to what was causing the water to boil. When we get to the back, what you're going to do is this is going to be now, you could have done the first half before the notes and then the second half gets done after, or you could just do the whole thing after. What is the relationship between temperature and vapor pressure of a liquid? Explain. That is in your notes. 8, what was the vapor pressure inside the syringe changing when you pulled back on it? Why or why not? It definitely, the vapor pressure, well, I'm going to let you answer that one. And then what conditions of vapor pressure and atmospheric pressure must be achieved for a liquid to boil? That's right out of the notes. And 10, I want you to break it down. Okay, so for 10, I want you to say exactly what happened inside the syringe when you pulled back that led to the liquid boiling. So it's really kind of going to be like this. Step 1. So you pulled back on the syringe. What happened to either the atmospheric pressure or the vapor pressure? Step 2, something else happened. Step 3, because of what? Okay. And then I would add more steps in. If you wanted to do this in, you could break it down into 6 steps. You could break it down into 4 because you would say, well, 1, 2, 3 would be pulling back on the syringe, and then 4, 5, 6 would be letting go and returning the conditions back to normal. It's just reversing what happened. But basically, when you pulled back on the syringe, what happened to the vapor pressure and the atmospheric pressure? And because one of them changed, one of them didn't. And then if you do it in 2 steps, this would be step 2, and you would say, well, it boiled, and the reason it boiled was because these conditions were met. And then when you stopped pulling back on the syringe, well, these conditions changed this way. And then step 4 would be, and then it stopped boiling because of this. So you're going to break it down into a step-by-step setup. And then for the drawing on number 11, you're just going to draw the syringe. I'm not a very good artist, so I'm going to draw it the best I can. So there's my syringe, and here's my stopper that I put on, and then here is the plunger, and or beforehand the plunger was here, right? So there's the plunger, and then here's the water, and you would say that the water was at 70 degrees C, and it wasn't boiling, and then afterwards you pulled it back. I'm not going to draw the whole thing for you. So I pulled the plunger back to here, and then here was the water because it didn't fill the whole thing anymore, right? And then there's the cap, and then I would say, well, what's the temperature in terms of degrees C, and then what was happening and why was it happening? All right, and so you're going to do just the plunger. You don't have to draw the whole setup. And that's it for this lab.